Okay, this is Chemistry Unit 5. We're looking at video number 4 here. We are at the top of page 4. So we talked about groups 1 through 13. We talked about 15, 16, and 17. Group 18 is the noble gases. They're already stable. The only one we didn't talk about was elements in group 14. And they don't tend to form ions at all. So rather than trying to gain 4 electrons or lose 4 electrons, group 14 elements generally share 4 electrons. And they form something called covalent bonds, which is a completely different unit. If you take an organic chemistry course when you get to college, you're going to study the behavior of these elements, especially carbon, in depth. So we're talking about ionic bonds now. So a chemical bond is a more general term. It includes both ionic bonds and these covalent bonds. So that's a general term. A chemical bond is a force that holds 2 atoms together. Ionic bonds are one specific type of chemical bonds, and it forms from the attraction between the positively charged ion and a negatively charged ion. So ionic bonds form when opposite charges attract. When opposite charges attract. There's a word for this when something positive and something negative attract each other, and it's called a Coulombic attraction. So be familiar with the term and what it means. It's really just an attraction between a positive and a negative. If you take physics, we'll talk about Coulombic attractions in a lot of detail. If you take AP chemistry, same thing, you'll see it in a lot of detail. Here it's just by name, it's just by idea. So we have opposites attracting, it's a Coulombic attraction, and the resulting ionic bond is extremely strong. So as we've seen, we have ions with different charges, different amounts of a positive or negative charge. And by that I mean we've seen nitrogens with a -3, we've seen sodiums with a +1, we've seen chlorines with a -1, we've seen magnesium with +2. So since they have different numbers of positives and negatives, we might have more than 2 atoms chemically bonded in the ionic compound. So you're familiar with a lot of ionic compounds. For instance, the salt that we put on food, and I'm going to put that in quotation marks because in chemistry, salt is a very general term. The salt that we put on food is an ionic compound, and it's composed of a sodium cation and a chloride anion. Another one, the rust on a piece of metal, is an ionic compound, and it's composed of iron cations, so positively charged iron, and oxygen anions. You're probably familiar with an ionic compound that's commonly found in most kitchens, and we're talking about baking soda. There's some general properties shared by all ionic compounds, or at least most. Ionic compounds tend to be electrolytes. So if we're talking about electrolytes, you're probably familiar with it in terms of Gatorade or Powerade or maybe Brondo. We're talking about in that specific instance, something like sodium, potassium, chloride, magnesium. It's the things that are coming out in your sweat and you're just trying to replenish your body's supply. What it means in chemistry is more general. An ionic compound tends to be electrolytes, or this is a substance that conducts electricity when dissolved in water. So the nerves in your body, they send electrical impulses, and the electrical impulses are caused by electrolytes. So your nerve cell works to pump some of them out of the nerve cell, and it works to pump some of them into the nerve cell. And then when the signal comes through, they intermix, and you get an electrical signal that goes very quickly. Electrolytes conduct electricity when dissolved in water. Water itself is not a very good conductor of electricity. It is the electrolytes that are dissolved in water that makes it conduct electricity. For instance, here in Indiana, there's a lot of calcium in the water. The calcium conducts electricity really well, but the water doesn't. The calcium is an electrolyte. Ionic compounds, in general, tend to be very hard, and they also tend to be somewhat brittle. So they're very hard, meaning that if you drug an ionic compound across maybe a whiteboard, it would just leave really deep scratches. But if you were to take that same ionic compound and set it on the floor and hit it with a hammer, it would probably shatter into a million pieces, and that's where brittle comes in. An ionic compound is typically composed of a lot of atoms that are bonded together. And they form this three-dimensional structure. There's positive ions, then negative ions, then positives, then negatives, all in this huge three-dimensional pattern. It's a network, and they call this a crystal lattice. So think about a grain of table salt, like just one grain of table salt. One grain contains approximately 6 times 10 to the 17th sodium ions and an equal number of chloride ions. Think about that for a minute. Look at this number. So you're talking about times 10 to the 6th would be 6 million, times 10 to the 9th is billion, and you have trillion. This is a very large number of ions. So we're talking about one grain of salt, which is extremely small, and so these sodium ions must be very, very small. There's an equal number of chloride ions. But when you look at it, a grain of salt is one solid piece. And this is because all of the ions are arranged in this crystal lattice. That three-dimensional structure, it's an orderly network of ionic bonds. And so I'll draw a small picture here. And I'm going to say that, this is going to represent a positively charged sodium ion, and this is going to represent a negatively charged chloride ion. And so what we see is not just one of these and one of these, even though the formula here is NaCl. But you see this huge three-dimensional structure of another sodium, another chloride, and it goes on and on. And I'm not going to do this for a whole lot longer because I'm never going to reach this number. 6 times 10 to the 17th of these sodiums. And right now I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. And it goes on. You could do this for as long as you want. You would never reach this number. So I'm going to leave it at that. And this is our crystal lattice, that three-dimensional structure or the orderly network of ionic bonds.